Alright, so let's go ahead and do multiplying polynomials. Our objective here is to multiply polynomials. I like it when these titles are just like, kind of match the objectives and keep things simple. Anyways, my BQ for today is going to be which method of organization do you prefer for multiplying polynomials and why? I'll show you which one I prefer, and you'll kind of see why. But whichever one you might prefer, and if that's the one that y'all want to go with, then let me know and I can show you more examples with that. So there's going to be some examples. I'm going to show you in my preferred method. I'll show you in all the methods, but I'll show you my preferred method also for several examples. But if you prefer a different method, that's okay. I can show you examples in that method. Just make sure you ask the next time I see you in class. So from here, what we're going to do is we're going to do some monomial multiplication first. Now, keep in mind with monomial multiplication, we should first make sure we multiply the coefficients, but only add the exponents. Okay, so like 6 times 4 was 24, but then with the exponents, and it doesn't matter if these letters are different or if the exponents are different. Here we just go, okay, I've got an A, and then I'm going to say 4 plus 3 is 7. So my final answer on this one is 24a to the 7th. Okay, another example, 5a to the 5th, b, 7ab to the 3rd. So I would say 5 times 7 is 35. A to the 5th times a would be a to the 6th. 5 plus 1 would be 6. And then 1 plus 3 would give me b to the 4th. So hopefully that one, like I said, these shouldn't be too easy, just a quick, easy multiplication. So one more example here, negative 4m squared n cubed times 5m to the 5th n to the 4th. Okay, so 5 times negative 4 would be negative 20. M squared and m5 would give me m7. So add the exponents and then add 3 and 4 to get n7. So it's m to the 7th, n to the 7th. So negative 20, m7, n7. Okay. Now, what happens if I have a monomial times, say, a binomial, a trinomial, or any polynomial? Well, it's distributive property. Remember, when we did something like this at the beginning of the year, we said 4 parentheses 5x plus 7 equals, and we would say 4 times 5 is 20x, and 4 times 7 is 28. Well, you can do something very similar when you have like 3x times, say, 5x plus 7. Where there I would say, okay, 5 times 3 is 15, but x times x would give me x squared, because I'm saying 1 plus 1. And then I would say 7 times 3 is 21, but then I can't forget the x, and there's my x. Okay, obviously I'm recording this at school, so you can, because you heard a bell. So there you go. Gotta love that. Anyways, all right, so let's look at another example. How about a slightly bigger one? 2x times 3x squared minus 4x plus 9. Okay, so I'm going to say 2x times 3 is 6x. But again, 1 plus 2 is 3. 2x times negative 4x is going to be negative 8x squared. And then 2x times 9 is positive 18x. Now notice here I did say that as a negative, and I said this as a positive. So I said positive 2 times negative 4 gave me a negative 8. So I did treat that minus as a negative as I'm doing this multiplication. Alright, so now let's get to binomial multiplication. This is what we normally think of with multiplication. And there's really... Okay, I got disturbed there, so I'm not sure. Okay, so let me go again. There's 3 different methods that I identify. I know the book is going to talk about something different. Really, these are just different ways of organizing. Okay, and the FOIL method they're going to talk about, you can look at it in the book, is really the distribution method, just kind of a specialized. And I really don't like talking about FOIL, so I'm not going to. So we have the distribution method, the box method, and the vertical method. So let me show you a little bit of every single group. Gotta love those bells. Alright, so here we have an example, x plus 2 times x minus 5, and I'm going to do this by distribution. Now what distribution says is that you take that first parentheses and you split them up. So you're going to say that whatever's in the first parentheses, the x, and multiply it to the second parentheses. So you're going to say like x times x minus 5. And then you're going to write the second part of that parentheses plus 2 times x minus 5. So you're distributing this, the first parentheses to the second parentheses, but by splitting them up. Okay? And then now you need to do distributive properties. Say x times x is x squared, and x times negative 5 is negative 5x. 2 times x is 2x, and 2 times negative 5 is negative 10. Now if you look in the middle, you can see there's two terms that are like terms that you can combine. So you now have x squared minus 3x minus 10. Okay, and then that's it, you're done. Okay, so generally on this, you want to multiply, and then you'll see if you have some like terms. Again, this is distribution method. Let me show you the exact same problem, but with the box method. Okay, so we're going to do again the x plus 2 times the x minus 5. Now, if you've been in biology and y'all have talked about genetics and Punnett squares, then this will look similar. Okay, so what I do is I write the first parentheses like on top. So I'm going to put here x plus 2. Notice how I put a box. You put a box for every term. So x plus 2, box, box. X minus 5, box, box. Okay, then you can multiply. Well, x times x is x squared. X times 2, so I'm taking this x times that 2. X times 2 is 2x. X times 5, negative 5, is negative 5x. And 2 times negative 5 is negative 10. Now again, if you notice, these two boxes have like terms. So combine them. So to write it out, you're going to write x squared. 2 minus 5 is negative 3. And then minus 10. And there's your answer. Okay, so again, that's the box method. If you know Punnett squares, then that should look fairly easy. Okay, so finally, the vertical method. This is the method that I prefer. And I prefer this because it's kind of like what you used to do back in elementary school when you did like two-digit multiplication, which would have been like, okay, 13 times 12. I'm going to go 2 times 3 is 6. 2 times 1 is 2. And then I'm going to go to the next row, and I'm going to put a 0, and then say 1 times 3 is 3, 1 times 1 is 1, and then I can add. 1, 5, 6. So 12 times 13 is 156. All right, same idea. Okay, x plus 2 times x minus 5. Okay, notice how I've written them one on top of the other. Okay, so your first one, do 2 times negative 5, or negative 5 times 2, which is negative 10. Then we do negative 5 times x. Same way that we did 2 times 3, 2 times 1. Negative 5 times x is negative 5x. Next row. So now for the second row, I'm going to go ahead and put a 0, because look, again, we put a 0 when we start off, so that's like our placeholder. So when we start the next row, we put a 0. Then I'm going to say x times 2 is 2x. Notice how it lines up under the negative 5x. And then x times x is x squared. So now I can just drop straight down and everything's already organized. This is why I like this method, because look, I can go x squared, negative 5 plus 2 is negative 3, and then negative 10 plus 0 is negative 10. And you're done. And that's the vertical method. So again, I like the vertical method more, so you're going to see more examples with me doing the vertical method. But if you wanted me to show you, say, the box method or distribution method more, then just let me know, and I'll do more examples with those in class. So our next example is going to be 2x plus 1 times 3x plus 4. So I'm going to move the 2x plus 1 under the 3x plus 4. And then I'm just going to go 1 times 4 is 4. 1 times 3 is 3x. Put a 0. 2x times 4 is 8x. And 3x times 2x is 6x squared. So I bring it down. 6x squared. 8 plus 3 is 11x. And then 4 plus 0 is 4. And you're done. That is it. And that is again why I like the vertical method. Next example. Here I have 5x plus 3 squared. So that means 5x plus 3 times 5x plus 3. Remember, the square means a number times itself. So I'm saying 5x plus 3 times 5x plus 3. So then I can go 3 times 3 is 9. 3 times 5 is 15x. Put a 0, next row. 5 times 3, 5x times 3 is 15x. And 5x times 5x is 25x squared. Bring everything down. 25x squared. 15 plus 15 is 30. And x. And then 9 plus 0 is 9. And again, you're done. Now this type of problem, because it is a square, is called a perfect square trinomial. How do you know it's a perfect square trinomial? There are, well, one, there's 3 terms. 1, 2, 3. Okay? And 2, if you notice the ends, and I mean by ends, I mean the 25 and the 9, those are perfect squares, because 5 squared is 25, 3 squared is 9. So that is why this is a perfect square trinomial, because it's 3 terms, and then the end ones are squares. That's important for, say, to make sure you note and make sure you put maybe on a note card. Okay, this one right here is called a, well, we'll see what it is. But we have 7x minus 8, 7x plus 8. So I'm going to rewrite 7x minus 8 under the 7x plus 8. And I'm going to say negative 8 times 8 is negative 64. Negative 8 times 7 is negative 56x. Then I'm going to start the next row and put a 0 and say 7x times 8 is positive 56x. And 7x times 7x is 49x squared. When I combine everything, I notice that the middle terms cancel out. They become 0, because 56 minus 56 is 0. I really don't need to write it like this, so I can just drop that 0x and just write 49x squared minus 64. This type of answer is a special answer, also known as the difference of 2 squares. Again, difference meaning there's a minus in between, and there's only 2 terms, so that gives you 2 squares. Notice that 49 and 64 are squares. That pretty much covers multiplication. It is a little bit longer notes than usual, but it does. This notes all really kind of covered 2 sections. So we will get plenty of practice over the next 2 days, but I was able to get this into 1 set of notes. If you do have any questions, make sure you ask, because this is something where I can spend that extra time answering. All right? Again, thank you very much, and I'll see you when I see you.